Welcome to solverfy.
All right, for this problem, we are looking at internet datagrams. I won't read out the full description here, but what concerns us particularly is that we have the total length field, which is 16 bits. And I'll touch on the other information given as we go through and solve the problems. But for part A, we want to figure out the largest possible value of total length. And we know that the total length determines the maximum total length in octets, which are sets of 8 bits. So we know that total length has 16 bits, which means that the largest value, so max of total, we'll just call that TOT dot for short. The max of the total is going to be 2 to the power of 16, because it's 16 bits. And also, we can't have a number here where we just have the, we can't have all of the digits filled in. So the maximum value is actually going to be 2 to the power of 16 minus 1, which equals 65,535 bits, which then equals 8,100 or approximately 8,192 octets. For part B, we are asked about, we're given that we are asked that the largest possible value of the hlen, which is 4 bits long, determines the maximum total header length in 32 bits. We want to figure out the value and the maximum total header length in octets. So we know that hlen is 4 bits. So the max is going to equal 2 to the power of 4 minus 1, which equals 15 blocks, which are 32 bits. So the maximum number of bits, maximum amount of octets, rather, we were asked about octets. The header number of octets is going to be 15 times 32 divided by 8, which is going to work out to 60. For part C, we have the minimum and most common header length is 20 octets. What is the maximum total length in octets of the data area of an internet datagram? So we figured out in part A that the maximum possible was 8,192. So we have max tot. Actually, I'll write it out slightly differently here. We'd have that the max data is going to equal the max tot, C daisy, max tot minus max header, which would equal 8,197 octets minus 20 octets, or simply 8,177. Oops, 77. Where did I get that from? Sorry, up here, that should have been 8,192. And then down here, it should be 8,172. And lastly, for part D, we're asked how many different strings of octets in the data area can be transmitted if the header length is 20 octets and the total length is as long as possible. So we'd have that the data is going to be 8,172 octets, which equals 8,172 times 8 bits, which then is going to equal 65,376 bits. Therefore, in terms of number of possible strings of octets, well, it's going to be 2 to the power of 65,376.